Okay, so welcome to the video. In this video, we will be doing this multiple select question asked in IIT JEE 2023 Advanced Paper 1. So you can pause the video and read the question. Okay, so hoping you have read the question. Let's solve it. For solving it, first we need to find U0. U0 is the velocity with which the ball is leaving the terrace. For finding that, I am taking the top of the terrace as a ground and using conservation of energy. Okay, so this is the initial position and this is the final position at first. So from top of the terrace, the ball is at a high touch at the initial position and it is at rest. So uh, the initial energy is purely potential and it is mgh. Simple. And uh, as I chose this as my ground, at this position, the energy is purely kinetic. According to this ground, not the actual ground, according to this ground, the energy is purely kinetic and it is half m, sorry, half m u dot square, as u dot square is a u zero square is a velocity. So the only force acting here is gravitation, which is conservative. So mgh must be equal to half mu zero square according to conservation of energy. So from this, u0 is equal to root 2 gh. And you can see at the end the slide is becoming horizontal. So u0 will be along x-axis or the horizontal axis, which is here x-axis, so x cap. So option A is correct. Option A is correct. Now we need to find v and theta. For that, we need to find the velocity with which the ball is hitting the ground. The actual ground, not this ground, the actual ground. So that's a simple question of free fall. Initially, the vertical velocity is zero. The velocity is truly horizontal here. So a body at rest. This can be compared to a body at rest, free falling. The height is 3h, and we know to find the velocity of the ball when it reaches the ground, we simply do root 2 gh, where h is the height. Here, the height is 3h. The height from the ground to the top of the terrace. The height from the ground to the top of the terrace is 3h. So the velocity will be, the vertical component of velocity will be 2g into 3h. 2g into 3h, that is root 6h. Root 6gh. Root 6gh. So uh, so the total velocity is Vg. Let's name it as Vg, as we have another V here. Vg is the velocity with which the ball is hitting the ground. The velocity with which the ball is hitting the ground, that is this velocity, Vg. Vg is the horizontal component is not changing here, so it is root 2 gh only. So root 2 gh x cap plus root 6 gh z cap, which is the vertical component here. Z is a vertical component here, as you can see. Now, for finding theta, theta is simply, we know, uh, tan theta is simply Vz by Vx. That is a vertical component of velocity by horizontal component, and it is root 6 gh by root 2 gh, that is root 3. So theta is tan inverse root 3, which is 60 degree or pi by 3 radian. 5 by 3 radian. So option C is correct. Now for finding V, we need to include the effect of coefficient of restitution, and this is an important point that you must study. There is a coefficient that you must know, that the coefficient of restitution will not have changed the component of velocity along the bouncing surface. That is, here the bouncing surface or the ground is along x-axis. So the component along x will remain constant and the component along z will be affected. So the component along z is now root 6 gh So the coefficient of restitution here given is 1 by root 3. 1 by root 3 z cap. So the velocity will be root 2 gh x cap plus this will give root 2 gh z cap. That is root 2 gh into x cap plus z cap. Actually, you can eliminate option B very quickly because here it is given minus z cap, and you know that will not happen because the ball is going in this direction and z should be positive. Z can be negative, so this option can be eliminated, and you should use that kind of tricks in entrance exam as time is your biggest enemy there. Now, okay, so we got V as root 2 gh into x cap plus z cap, so this option B is wrong. Now, for finding h1. H1 is simply what you can find as what v square is equal to u square plus 2gs. We can use that, and but when reaching the top, this is simply a question of free fall again. When you see when reaching the top, the v velocity will be 0. So u square is equal to 2gs, and s, that is height, will be u square by 2g. So here it is uh, v z square, that is z component of v square by 2g. Here it is the z component of v, that is after bouncing the z component of v. The z component of this velocity is root 2 gh as we just found. So it is root 2 gh square is 2 gh by 2g. So it is h. Now for finding d, that is that d is this distance, the distance between the our terrace and the actual the first landing point, the distance between terrace and first landing point, d. For finding that, we need to find the time of fall, the time of fall, which is simply again a question of free fall, that is root 2 into height by g. The height is 3h, height by g, that we will get as root 6h by g, root 6h by g. Now the d is the horizontal velocity into time. Horizontal velocity undergoes no change here, and it is u0, and u0 we have found as root 2 gh. So we will get d is equal to root 2 gh into root 6 gh. I mean root 6h by g. I'm sorry, root 6h by g. Root 6h by g. So we will get it as the g will be cancelled, and we will get a 2 outside, 2 root 3 h. We will get it as 2 root 3 h. So d by h1 will be 2 root 3 h by h1 is also equal to h, as we just found. H1 is also equal to h. So 2 root 3 h by h, that is 2 root 3. So option D is also correct. So the correct options here are A, C, and D. This was a good question, but a simple question. It can be solved if you know the basics of what kinematics and this coefficient of restitution. So thank you for watching.